This lake holds a lot more water than this pool. We can say the lake has a greater volume of water. What is volume? How can we calculate volume? And how does something called density relate to volume? During the next few minutes, we're going to explore these questions and others as we investigate volume and density. This bird has volume, and these soccer players have volume. Simply put, volume is the amount of space that something takes up. Everything we see takes up space and has volume. Even things we can't see, such as gases, take up space and have volume. You decide. What has more volume? This box of matches or this box of cereal? That's right. The box of cereal has more volume. It takes up more space. Volume is often described in cubic units. A cube has 3 dimensions: length, height, and width. A common cubic unit of measurement in the metric system is the cubic centimeter. This is a cubic centimeter. It has a length of 1 centimeter, a height of 1 centimeter, and a width of 1 centimeter. Other common cubic units in the English and metric system include cubic inches, cubic feet, cubic yards, and cubic meters. This box is referred to as a rectangular prism or as a rectangular solid, whereas this construction equipment has an irregular shape. If we have a tape measure or measuring stick, such as a ruler, it's not difficult to calculate the volume of regularly shaped objects. Let's calculate the volume of this regularly shaped box of raisins. To find the volume of regularly shaped containers, we use a simple formula. The formula is volume equals length times height times width. Using a metric ruler, we measure the length to be 5.3 centimeters, the height to be 7.4 centimeters, and the width to be 1.8 centimeters. When multiplied together, we get a volume of about 70.6 cubic centimeters, expressed as centimeters to the 3rd power. Remember our cubic centimeter? It measures 1 centimeter long by 1 centimeter high by 1 centimeter wide. When we say that this box has a volume of 70.6 cubic centimeters, you can think of it as containing over 70 of these small cubic centimeters. We just took a look at volume, but what is something called mass? Mass is the amount of matter in something. Often, we think of mass as the amount something weighs. This shark has a lot of mass, whereas this fish has a small mass. Bricks like these are used to construct chimneys, sidewalks, walls, and buildings. Foam is another useful material used to package things and also is used for insulation. Both objects have mass and volume, but these objects differ greatly from each other in volume and mass. Let's see how. This brick has a length of 20 centimeters, a height of 5.5 centimeters, and a width of 8.5 centimeters. When multiplied, we calculate its volume to be 935 cubic centimeters. This piece of foam has a length of 40 centimeters, a height of 4 centimeters, and a width of 25.5 centimeters. When multiplied, the total volume of the foam is 4,080 cubic centimeters. As you can see, the foam has a lot more volume than the brick. You decide. Which of these objects do you think has more mass? Let's use a scale to measure the mass of each object. When placed on the scale, we see the brick has a mass of about 2,400 grams, whereas the foam has a mass of about 100 grams. So even though the foam has more volume, it has less mass. You decide. To avoid injury, what would you rather catch? A small brick or a large piece of foam? Of course, you'd rather catch the large piece of foam. But why? The answer has to do with something called density. Density is the measurement of how much mass is contained in a given volume. Put another way, it's the amount of matter or stuff jammed into a specific space. If we loosely pack this bag with socks, it's not very dense. But if we tightly stuff it, the bag has more density. Here's another example. Each of these 1-liter bottles has a volume of 1,000 cubic centimeters. The bottle on the left is being filled with cereal, while the one on the right is being filled with stones. Of course, the bottle with cereal has much less mass than the bottle on the right. Keep in mind that both bottles contain the same volume of materials, but the bottle on the right has a much greater density. You can see the denser bottle sinks in water, and the less dense bottle floats in water. The density of objects in the metric system is commonly measured in units of grams per cubic centimeter. Fresh water has a density of 1 gram per cubic centimeter. Objects that have a density of less than 1 gram per cubic centimeter float. Objects that have a density of greater than 1 gram per cubic centimeter sink. We know that water has a density of 1 gram per cubic centimeter. How can we figure out if a block of wood will float without placing it in water? We already discussed that density is the amount of mass per unit of volume. This can be expressed as a mathematical formula where density equals mass divided by volume. Therefore, if we know the mass and volume of the piece of wood, we can compute its density. Let's first obtain the mass of the block of wood by placing it on a triple beam balance. You can see that its mass is about 207.4 grams. To find its volume, we need to measure the length height, and width of the piece of wood. We get a volume of about 386 cubic centimeters. Next, all we have to do is divide the mass by the volume. We divide the mass of 207.4 grams by the volume of 386 cubic centimeters to get a volume of about 0.537 grams per cubic centimeter. The density of the wood is 0.537 grams per cubic centimeter. You decide. Based on this information, will the wood sink or float? The block of wood will float because it has a density of less than 1 gram per cubic centimeter. Objects with a density of greater than 1 gram per cubic centimeter sink. During the past few minutes, we explored some of the fascinating aspects of volume and density. We began by learning that volume is the amount of space something takes up. And we investigated how the volume of rectangular prisms is calculated. We then explored the relationship between volume and mass. This information helped us understand density. Last, we learned how to calculate density. So, the next time you need to figure out how much space something takes up, or calculate the density of an object, think about some of the things we discussed during the past few minutes. You just might think about volume and density a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. Volume is the amount of something takes up. Number 2. Is the amount of matter in something. Number 3. The volume of rectangular prisms is calculated by multiplying length times height times. Number 4. The formula for density equals mass divided by. And number 5. When placed in water, objects with a density of greater than 1 gram per cubic centimeter will.